Hi, I'm an old guy and I do maths. Today we're looking at prime numbers. These things are really useful and I don't think they're adequately understood. What is a prime number? It's a number whose only whole factors are 1 and itself. So 2 ones are 2, 3 ones are 3, 5 ones are 5, 7 ones are 7, but 3 threes and 9 ones are 9 and so forth. So that explains why 9 is not in this list, nor is 15. Probably up to about 13, I would say, is a good list of prime numbers to know. So just to go into the business of factors a little more, 3 threes are 9, but 7 can only be found by multiplying 7 and 1. Go through your times tables. Think about how you find 7. Well, the only way that you can multiply to get 7 is 7 ones. Division doesn't count, so 21 divided by 3 equaling 7 does not count. This is about multiplication. Anyway, 3 threes are 9, 3 fives are 15, and 4 sixes are 24. None of these is prime. This one is, for that reason there. Now, what is the use of this? Well, again, looking at where this video is pitched, and the reason that this came up was I said to a student of mine, you cannot simplify that fraction any further because you're dealing with prime numbers. And they looked at me and really did not appear to understand. So let's look at how this works with fractions. Specifically, it's handy when you're simplifying fractions. Now, we've got a fraction here, 4 over 28. Now, the general rule is that if you've got two even numbers, you can halve the top and the bottom of the fraction to simplify it. Now, in this case, we can simplify it further, and we get 1 over 7. 2 divided by 2 is 1, 14 divided by 2 is 7. Now, it just so happens that 2 and 7 here are prime numbers. 1 isn't. 1 doesn't count as a prime number. This is not really an example of where you have to stop because you've hit a prime number. But this case is. So let's have a look here. 2 over 13. All I've done is halve this fraction. Now, you absolutely have to stop because you've got two prime numbers. The other reason you have to stop is that 13 and 2 don't have any common factors. An example of where you don't stop is something like this, 3 and 9. Although 3 is a prime number, 3 goes into 9 3 times, and so that equals that. But something like this, you have to stop for two reasons. Both of these are prime, that's one reason. The other reason is that 2 won't go into 13, which is probably the more significant reason. So lastly, I've chosen to look at this fraction, 18 over 33. Now, we don't have two even numbers, but we can find common factors. 3 goes into 18 6 times. Now 6 is not a prime number. It goes into 33 11 times. 11 is a prime number. The search is over. You don't even have to ask yourself about whether 6 goes into 11 or not. Pretty much the same as you didn't have to ask yourself here. You struck a prime number in the denominator, and that pretty much finishes your search to simplify. So that's just one fairly basic use of prime numbers, but it's an important one and it does save time. Anyway, this is your introduction to prime numbers. The simple definition, just to repeat it, is that their only whole factors are 1 and themselves. And just like people who memorize pi, some people memorize prime numbers as far as they can. The search actually goes on for prime numbers, and every now and again one turns up. they get further and further apart the larger numbers get, and so the search becomes more difficult. Anyway, that's just a piece of useless information. Thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.